Hello, everyone. Thank you for attending today's webinar, Cellular, the Missing Link for Drones, presented by GSMA. I'm Monica Alvin, and I'll be moderating this webinar. Our speakers today are Barbara Pereglio, Technical Director, Connected Living Program at GSMA, Christophe Francois, Senior VP of Marketing at AirMap, Ralph Schupp, VP Program and Program Management, Group Technology at Deutsche Telekom, and Samuel Flick, Sales Manager, Central Europe at Microdrones. A few technical notes before we get started. If you'd like to download the slide deck, please click the Resources List button at the bottom of your screen. The webcast is being streamed through your computer, so there is no dial-in number. For best audio quality, please make sure your volume is up. You can find additional answers to some common technical issues located in the Help button at the bottom of your screen. This webinar is being recorded and will be available on demand within 24 hours after the event. We will follow the presentations with a Q&A session. Please submit your questions using the Q&A button on the left side of your screen. Okay, let's get started. Barbara, please go ahead.
Thank you, Monica. Welcome all, and thank you for joining this webinar today. What I would like to do is give a brief introduction of what is GSMA, what we are doing in the drone space. So just as information for all of you that don't know what GSMA is an association which represents the mobile industry and has been founded since 1987. The major work that we did is to try to have a global interoperable communication network. And you might be aware that most of the work is related to roaming. So all of you are advantages by using roaming today. As you can see here, there's quite a few offices worldwide to cover the global footprint of GSMA, and we have quite a wide variety of members as listed in this slide. So what I would like to give you is give it a bit more information about what we are doing in the area of drones. We started in 2016 to work and investigate the opportunity of using mobile networks in drone space. And nowadays, we can see here, we have created this drone interest group, and we have quite a wide variety of members. As you can see here, it's about 34, 35 members that we have nowadays. And they range from mobile operators and vendors, industry vendors that we have in the mobile industry. What we have done so far is investigate and analyze the mobile network and the advantages and benefits of using mobile network for supporting drone operation. One of the most important work that we did is also to advocate and list what are the benefits of using mobile network. As you can see here, some highlight of the benefits are first and foremost the standardized and scalable solution for worldwide connectivity. This is based on the fact that we use a well-known global standard defined by 3GPP. The ready-to-use infrastructure, nowadays we can say we have more than 5 million cell towers globally, so we have quite an advantage of having an infrastructure ready to be used. And the license spectrum, which is very important because it gives the opportunity to better manage the resources and also provide quality of services. Foremost is one of the advantages of mobile network is the inherent of having a secure communication. We can also support law enforcement in different aspects, and you will see also later on what would we mean by that. And more important is the fact that we will be able to identify drones, but also drones pilots and other aspects, and the drone itself by using the identification that we already have in our system, like the SIM and the IMEI. What we have done is analyze some use cases, and in this example, we have focalized mainly on commercial application for drones. And we have here about 5 categories that we looked at: inspection and survey, the communication and media, surveillance and monitoring, transport and logistics, and disaster response. These are the cases that we analyzed for developing them some publications. The publication that we're talking about is there are 2 types of publication. One publication which is called Mobile Enabled Unmanned Aircraft, where you have the link there, you can download it, it's a publicly available document. This document analyzes the capabilities and the benefits of the mobile network more in detail. It's the fact that it's using again, is analyzing how we can use the capability that we have nowadays in the currently available network for identifications of the unmanned aircraft in the mobile network, the different type of communication aspects and the real-time data, the security aspects that are very important in the drone operations, position and location services and no-fly zones, and foremost also the evolution of the mobile network in a standard in order to support better and evolve the network to have a better UA operations. The other document that we also worked on is touching more on the regulatory aspects, and we're talking about position. GSMA has created a policy position that will support the discussion with the policymakers and regulators to explain what are the benefits of using mobile networks, how we can provide safe operations by using those mobile network, not only but also to how we can fulfill the requirements from the policymakers. Again, you have a link below on the slide where you can find these positions, and it's available also for all of you. Said that, I would like also to tell you a little bit about what we're doing next. We are planning to also look at more in detail how a mobile network will support UAV, UAS traffic management. So we will publish soon, very soon, I presume we will be able to provide you the document next month for download. In this document, again, we'd analyze how mobile network will support UTM. Therefore, in a further presentation, you will see a little bit more detail what are the benefits of using cellular network for supporting UTM. We will also continue to lobby our policy position and try to encourage to have a positive and global aligned regulations across the globe. We're also going to publish a case study regularly, so please constantly check our website. You will see how mobile network is already being used effectively by deploying solutions that are used in drones nowadays. At the moment, we have one use case that is like that, but soon we will also have other use cases available to all of you. With this, I would like actually to pass to the next speaker. So I introduce Christophe, that will from Wrapup. Please, Christophe, over to you.
Yes, hello everybody. Thank you very much. So thanks for the transition. The topic of my speech will be to discuss a bit more in detail how cellular networks and connectivity can augment UTM services. So UTM stands for unmanned traffic management, and we'll talk a bit more about this, which is a critical infrastructure to support drone operations. The first thing I wanted to share with all of you is some statistics about the drone market. As we all anticipate, this is a very promising and high-growth market. Here you can see some projections for the global install base, which is forecasted to reach over 45 million units globally by 2022. So that, compared to the manned aviation industry, that's much bigger scale. Today, I think there are about 50,000 commercial airlines flying every day, about 100 or 200,000 flights a day. But the drone is a totally different scale. The majority of the volume so far has been really in hobbyist and consumer drones, but the majority actually of the value add is coming from business and industry operation. And if we look a bit more into the details of the type of missions and what the drones are used for, what is really striking is that this is a quickly evolving journey. So originally and still today, many drones are used as for hobbyist or recreational drones, and they come, to the market with price points below 1,000 euros and enable a lot of remote photography or video streaming. But today, most of the drones are really actively used by industries and enterprise, specifically in sectors such as infrastructure for linear inspection of critical infrastructure such as railways or electricity grids, as well as mining, agriculture, public safety, and construction. So there are a wide variety of application, and the type of mission is evolving towards much more autonomous or semi-autonomous flights and beyond line of sight flight. And this is where to sustain the evolution of those use cases, smarter connectivity and data processing are needed to support those missions. In the future, of course, what the industry foresees is drone as a service, where effectively the enterprise or the customer will be able to just order a mission and get the result of that mission and the data directly online. Before we see in the farther future eVTOLs and drone carrying passengers across populated areas. So if we look a bit more into what UTM is doing and what AirMap is doing, so AirMap is providing this infrastructure platform, which is called UTM, and which basically connects national airspace authorities and local authorities with drone operators and fleets to provide all the critical services which support those drone operations. And typically those services include providing awareness of the airspace and the rules and the applicable rules and regulation to each type of missions, as well as enabling the operators to fill their flight plans and get authorization from the authorities in real time. The system also provides global situational awareness about all the flights, whether this is manned aviation or unmanned traffic through telemetry, which is transmitted to the platform and communicated live to the airspace managers as well, the different operators. So that's a critical infrastructure to enable the orchestration of drone mission and drone flights at scale. Just to give maybe an example here, a bit more concrete, this is an example of delivery missions which are carried on today routinely in Switzerland by Matenet and Swiss Post with SkyGuide. SkyGuide is the air navigation service provider of Switzerland, working with AirMap, its UTM platform, and using the platform services. So Matenet is today delivering time-sensitive materials, medical materials between hospital in the Bern area, and this is one of the first program where your BVLOS is implemented on a routine basis for drones. So if we want to be a bit more specific, and Barbara already talked about this, there are many ways we see today and in the future how cellular connectivity can enhance the UTM operation. As you know, today most of the drones are piloted locally using Wi-Fi or similar protocol as the radio link to command and control the drones. But actually, we see more and more use of cellular networks to provide remote identification and tracking. So basically adding some cellular module to the drone, and I'm sure Ralph will talk more about this, to collect telemetry and positioning information into the UTM system to provide real-time awareness of the drone position into the system to airspace authorities. Telemetry acquisition can also be done natively, embedding an SDK and some software and using the local connectivity link, but obviously using cellular adds more reliability and tracking to the drone ecosystem. The second application, which is much more mission critical, is to use the cellular networks for command and control. And obviously this means that the drone is directly connected for command and control to their remote operator over the wireless network and the internet. And that use case enable, for example, remote piloting of drones, as well as support for BVLOS flights. This comes with the higher requirements on the cellular networks, of course, as this has become a critical link for supporting the drone mission. Two other applications that are also used is to use the cellular networks for live streaming and video capture. So this is, for example, can be used in public safety use case, a first responder or media, to transmit live streaming directly from the drone to the command center or to the customer using the drone to collect those information. Last but not least, and this is a real example already live in Switzerland, we can use the information that is crowdsourced by the cellular networks to provide live density maps of the population. And this is a great data source to assess the ground risk for certain drone mission, and also optimize the routing of the drone flights to minimize those risks. Just to maybe illustrate a bit more today how cellular is used in case of command and control, and there are already a number of mobile operators around the world doing those missions. So those are just for the sake of example, but for example, AT&T is using drones already to provide some LTE coverage in case of an emergency, and also provide dedicated coverage to other drones through their LTE networks. And that's one of the experiments they're carrying right now with AMAP in San Diego. Another example is from Uevia, which is a startup from France, which has an end-to-end system connected through LTE, and which enable drones to be totally remotely piloted. So the pilot doesn't need to be on site to carry on inspection or surveillance operation. So just maybe to conclude, I think there is a number of value add that the cellular networks can bring to augment UTM services, and cellular will be more and more critical to the future of drone operation. Nevertheless, that comes with some critical requirements on the network, specifically for low latency, obviously for command and control and for video streaming, as well as reliability of the coverage and classes of service, so that if cellular is used for command and control of the drones, this radio link is always prioritized over other services, as this is critical for the safety of the mission. Last but not least, the way the aviation industry works, and especially for advanced operation, and drone mission that are qualified as medium or high risk, meaning that they are either flying near to people or other people, or crossing airspace which can be used by other aircraft. Those missions needs to comply with safety requirements and risk profile, which are extremely strict and well defined. So here are two examples that are coming from projects that are carried with by AMAP with partners, and you can see that the higher risk of the mission, the higher the requirement on safety is, which means that in that case the cellular networks become really mission and safety critical for the drone operation, and that may effectively impose new requirements on cellular networks, maybe adding redundancy and making sure that in no event the connectivity with the drone is lost. So with this, I wanted just to thank you very much, and looking forward to the questions. Thank you.
Thank you, Christoph. Am I live now?
Yes, you are.
Cool. This is Ralf, Ralf Schepp, Mr. Drones of Deutsche Telekom. Samuel, who comes after me, will be happy to see that fancy drone here in front of the page because it's a micro drone. However, Christoph, one remaining point where you just were relying on the latency of the services. Just to give you an impression of general aviation, their comms as of today, they live with a latency of up to 2 seconds, which is totally fascinating to me and explains somehow why the communication between pilot and tower is sometimes so critical. This is something where we definitely can add further value in the drone business. But let's get into the topic itself. So everything we do here within Deutsche Telekom with respect to drones, we do in a meanwhile strong partnership with the German ANSP, Deutsche Flugsicherung. So it's really a joint project for 1.5 years now. And I just want to give you a small impression of what we did so far, and maybe also where we are heading to in the near future. Let me first get to our famous Hookon device. It is actually a bridge technology, I would say. So we expect these kind of technologies to be part of every drone in the near future. I always compare drones at this stage of their life cycle with these kind of Palm Pilots or Apple Newtons you had in the late 90s. So basically offline devices which you had to synchronize in the evening with your calendar by pushing them into a sync station. This feels somehow strange for someone who lives as a digital native with smartphones and everything we have as today now, knowing that this all might work much better being properly networked. And for our aspect, this was the first step of getting a drone connected to what Christoph mentioned, was being a UTM or an integrated unmanned traffic management with the general aviation's air traffic management, the classical ATM systems. This small Hookon device simply delivers a position, a GPS position, and a barometric altitude, and tunnel it via a secure channel to the ATM system of the Deutsche Flugsicherung, which gives you a quite good tracking exercise. I have on 2 pages in front of us. So here you can see these kind of tracking examples. We did a lot of trials. Our Hookon devices send their position every second. So it's a real dense information stream, I would say. And this was somehow a prototype, and we are now pretty convinced that this could be really market ready because it's so precise. We have never expected it to be so precise. And it really works pretty well. The other aspect we're going to bring in, and Christoph mentioned it as well, is we also want to be every drone at least equipped with a SIM card for the obvious reasons of getting the ID handled, which is something the mobile industry does for billions of devices and smartphones every day, and which they could also do for the drones, but also for the reason of flying beyond visual line of sight, command and control, which you just mentioned, for the reason of a proper tracking, so a proper integration into the regular airspace, but also for simple data transfer. Why to wait until the drone lands unless you have to read out the SD card? you could send, let's say, live data from the drone into the network, into the cloud, seeing it processed there, and getting back to your work. Besides that tracking, we achieved something really great last year. We got the real first approved BVLOS flight in Germany. Microdrones was also part of that, so don't be shy here with that. What is that, a phantom? It's a fake, because true BVLOS looks like this. It's pretty boring because the drone is basically away. You don't see anything. This was a German motorway, a construction site, a Deutsche Autobahn, where we were flying roughly 10 kilometers out of sight. We had a very weak LTE signal here, so it was really challenging for us to get the drone started. But in total, we had a procedure in place which was totally fine for the local authorities, and which was that was the case. We got the approval for having this flight up and running. So sorry if I'm jumping through the slides. I forgot something to say about this fancy one. I don't know who of you were part of the Intergeo, which is a famous fair in Germany, and let's say one of the biggest drone fairs in Europe. And within Intergeo this year, I was totally astonished how many drone manufacturers in the meanwhile operate via LTE. So it was Dell Air, it was Globe UAV. There were a lot of players who really already provide LTE connected drones, which makes me somehow happy. On the other hand, this must happen in a controlled way. So I feel that it doesn't work without the permission of the operator, of the network operator, because this is also something we experienced. Having a big upload stream from the air can harm the network pretty heavily, and we think it is manageable, but it needs to be managed. Yeah, and that's why I'm on the one hand pretty happy to see more and more LTE drones popping up. On the other hand, I feel it must be really in line with the mobile industry and not just a free ride on it. So what we also produced, which was quite fascinating, we also presented at Intergeo a fully integrated drone from the company Unique. I think it's number 2 on the market behind DJI. And this integration was done by the Android provider of the drone flight computers, Auterion, which covers a lot of the market, more than half of the market, and which simply showed a really huge interest in how can you manage and integrate LTE and mobile networks into a proper drone setup. We're going to continue on this one. So jumping back to my BVLOS, and I'm going to accelerate a little bit. We did many trials in POX last year, and just to give you some impressions, we started not with the commercial ones, but rather more with the search and rescue ones, because we still feel that this drone market needs a little bit more of public acceptance. And we strongly believe that public acceptance comes with these kind of search and rescue missions, which aims to help to save people's lives. And with that, getting a good shape and a good mood. This was also something DJI mentioned at Intergeo at the European Drone Summit. They stated that drones have saved 172 lives last year. And I think this is something which has to be carried out much more in order to make this commercial drone market a real one. Also referring to Christoph, yes, this commercial drone market is still weak, I would say, in comparison to the consumer drone market. But we are really of the opinion that it's more related to the non-clearance of the regulatory framework. So we strongly believe that once you have a proper setup in place, where real and convincing companies are feeling safe with their drone operations, then this commercial drone market will pop up pretty fast, because they all do these kind of trials and they all want, but they are still waiting for getting the right solution in place which keeps them somehow safe. Some of these examples we have here. This is one of our favorite partners, ThyssenGas. It is a gas pipeline provider across bigger parts of Germany. They have 4,800 kilometers of gas pipelines, which they, as of today, have to regulatory overfly with a helicopter every second week. And they have, for sure, a strong interest in substituting these helicopters with semi-automated drone flights. These tests are based on LIDAR, which is laser scan technology, and really quite fascinating how this kind of real-time data transfer also leads to a much higher efficiency of these kind of inspection flights. Another one we did in the respect of agriculture was with Uni Hohenheim. Here it's all about getting, let's say, the acres scanned on a regular basis, getting cameras really detect where fertilizers have to be brought up, where pesticides have to be brought up, making that much more concrete. And there is a strong need in the market because, at least in Germany, the laws tend to allow the farmers only to bring out less and less of these kind of fertilizers and pesticides. And once you have such a technology in place, it gives you a reduction of 40 to 60% as of now, which is quite impressive, and with that respect also helps to save the environment. Just some more examples. We did this trial in Frankfurt at the Frankfurt Airport for a construction site inspection. This was somehow challenging because it's part of the control zone of the Frankfurt Airport. So we not only have to fly with the mobile network, but also with radar transponders in order to make them really visible to the towers. With our system, and this is pretty cool, the people in the tower, they can really detect and see these kind of drones as if would be a normal airplane. As an example, I show you that in the final two slides. This was more a fun one. We were also joining this year the first drone marathon, which has taken place in Berlin. There were a lot of drones in the air flying in that circle around 42 kilometers. And if you take a view on the next, the tracking worked pretty fine. But what was also happening, we had the full airspace control, and this is something which is then really unique. Near to this round circle of the drone marathon, we saw 3 times a helicopter, which typically would have caused to stop the drone race immediately because it was in line of sight. But in that respect, we were measuring this one. It was a search and rescue copter from the ADAC. Flying in here, and so we were convinced and really secure that we don't have to stop it, but having the complete airspace integration, the full view on the airspace in place. This was rather cool, and this shows a little bit on how we want to proceed here. Having these kind of drones really properly integrated into the airspace with the help of the mobile networks. That's for my part, and I hand over to one of our favorite partners, Microdrones. Samuel.
Thank you very much, Ralph. Thank you very much. Can you hear me well?
Yes.
I hope so. Good. So, yeah, also from my side, thank you for joining this webinar. I'm speaking for Microdrones, the UAV complete solution provider. My name is Samuel Flick, and I'm the sales manager for the Central Europe, the DACH regions for Microdrones. And I will present this LTE topic, the Beyond Visual Line of Sight topic, from a manufacturer side. As we know, the whole drone market is in a trend since years. Interested parties from the most different diverse areas are learning and have learned about the potential of drones, as we already heard. And looking at statistics, many of them shows that sales of drones have risen sharply over the last years. And what we see is that a lot of toys were sold, but since I would say 1, 2.5 years, we see that the trend goes directly in the professional solutions and professional applications. And as Ralph already said, is for this we definitely need better rules for the to manage the applications proper. Compared to conventional techniques, with drones we could be many faster, more accurate when it comes to, for example, mapping, and take much more data on what makes the job easier, as well as make more applications possible with drones. Likewise, the system could be quickly upgraded to additional tasks, like, for example, mapping or inspection purposes. And what we see is that the whole drone market currently is in a transition. So today the pilot here in Germany have to operate within the line of sight, as we have heard it. This for security reasons. Generally, it's not allowed to fly beyond the line of sight. So there are risks that you would like to avoid, for example, a danger to airspace participants or people on the ground. And this makes sense, but there should also be a way to allow these type of missions without having to take an increased security risk. To reduce the security risk, there are several options, and some of them we see now in this presentation. And my topic here is the safe execution of beyond visual line of sight surveillance flights, with a real life example, what we did with Telekom in this project Connected Drones. Quick outline. First, we see a brief introduction of microdrones, what we are and which kind of products we deliver. Next will be this real-life experience, and then we turn into benefits of the LTE drones. So what is microdrones? Microdrones is one of the first UAV manufacturers in Germany, founded 2005. We started in 2005 in Siegen with our commercial drone production. At this time, it was the UAV market was a pretty small market, but rapidly growing market, as we see today where we are. And since this market evolved over time, also a company grew, and we developed since 2005 drones to the need of our clients, and we're active in very different applications. Then in 2014, we got our North American alliance partner, a company called Avion, which we have merged in 2016. And in 2016, we start also our real commercial drone product line, as well as announced our partnership with the Trimble surveying equipment manufacturer, and deal with their dealer network, and have right now over 140 employees worldwide. Our main application are in mining, in construction, precision agriculture, as well as the oil and gas industry. The type of products what we deliver are products, or say it another way, that we are not just a drone manufacturer. We have products which are a complete solution. So that means we take the aircraft, we do the payload integration, and also do the software tools. And this ingredients at the end make the complete product line called MD Solution, and this could be a product line MD Mapper, MD LiDAR, or MD Detector, depending what is needed. So it's photogrammetry, light detection and ranging, or gas sensors. And as said in the beginning, nowadays operators are allowed to fly the drone in the line of sight range, the LOS range. For Germany, that means the pilot is allowed to fly in a maximum range of something of 400 meters radius to his position, or less if there would be obstacles in his way, like high buildings, bridges, or trees, or something like that. And since our systems are capable to fly for kilometers, this rule or these rules are a lock for the potential of them. So there need to be a way to make the beyond visual line of sight missions happen. So from the technical point as a manufacturer, what would be needed in the drone to fly beyond visual line of sight? First of all, the majority of the drones are equipped with live view, the remote control, and the telemetry data link with different ranges. The ranges here are fitted to the German rules. They're approximately ranges. It's really depending on the environment and of where we fly. So the links could be in a range up to 2 kilometers, really depending on where we fly. For a BVLOS project, and to make beyond visual line of sight flights possible, we added additional equipment to the UAV. One of them is the LTE, what we integrate into the drone. And given that we have network coverage, we get additional channels via LTE, such as RC also, live view, and telemetry. And to do these flights, we also added a FLAM module, which is a traffic awareness and collision avoidance technology. So this FLAM is made for general aviation, for light aircrafts like gliders, but also for UAVs. And with the FLAM installed, the operator is alerted of both traffic and imminent collisions with other aircraft. So he can take action before it's too late and you have a collision or you are on the way to a collision. And for the project, we also mounted the Hookon Device from the Deutsche Telekom and Deutsche Flugsicherung with what Ralf already mentioned to track the flights. And this all made this beyond visual line of sight flights in these projects possible from the technical point of view. So in this mentioned project with Deutsche Telekom and Deutsche Flugsicherung called Connected Drones, we flew a corridor of 12.6 kilometers in Germany with the construction giant Wrapup. It was an autobahn called A33. It's near the city Bielefeld. This is the case what also Ralf showed in his slides. For this project, we used our high-end mapping product, the MD-Map 1000DG, because it has the high-precision sensors on board, which enables the corridor mapping. These high-precision sensors are a calibrated full-format camera from Sony. This is the RX1R2 with a 35mm fixed lens, 42-megapixel full-format sensor. And on top of this, we integrated the Aplanix IMU, which locks the angle of the camera when it triggers a photo. And so we know exactly the position of the camera. The MD-Map 1000G also has a dual GNSS antenna on top of the drone to deliver high accurate positioning by combining with correction data from a service or a base station. And in this mission, we flew a height of 100 meters with an 8-meter vertical speed. The mission took 2 flight lines and worked with a ground sample distance of 1.2 centimeters for each pixel, which came out of the Sony's full-format sensor. And to fly this kind of mission, a BVLOS permission from the National Aviation Authority and submitting a specific operational risk assessment, which is called the SORA, was needed. That was from the governmental side. Yeah, we ended up with the result of 2 sectors of 5.6 kilometers and 7 kilometers with less than 1 hour of flight time. We took 1,493 pictures and processed them to a point cloud and an orthomosaic. And the accuracy of this mapping product, MD-Map 1000, provided an outstanding data of 3 and 6 centimeters in X and Y and 5 centimeters in Z. And with this system, we were able to use just a few smart targets as checkpoints instead of tons of ground control points on the path. And during this mission, and beyond visual line of sight mode, we switched our position just one time on the whole path. If we had done this mission in a line of sight range, we would have to change the position minimum 12 times or more, since we had curves and obstacles like bridges and trees on the flight path. And to the conventional methods, if we had done this mission in the conventional methods with a GPS rover or like something like that, we would need more than a week to create a map. And for sure, the mapping product out of the drone is much more detailed and much more data to what we calculate later and to where we can create the end products what we need to have. So from the manufacturer point, coming to the benefits of using links like LTE in the drone, there we see a good potential for the future. So we can say that we save time and money by using drones in these applications, especially flying in beyond visual line of sight mode. The PV loss is enabled on one hand through LTE, which also means that the LTE unlocks the potential of drones. But it's not just the LTE, it's for sure also unmanned traffic management system, which could make the flights safer at the end. And by using LTE, we could feed these UTMs with drone data to manage the operations. And also by using the LTE, the drone data is available everywhere we like. For example, we can fly a drone which is located in Cologne from any spot in the world. And to sum it up, drones are great technology for sure, and we deliver today high added value. But with rapidly growth and high potential for the future, the next step would definitely be to operate in general beyond visual line of sight. And for me, from my point of view, this is the task at the end. And so, yeah, thank you very much for listening. And if you have questions, please let me know. Also, after the webinar, you can reach us on microdrones.com. So, yeah, again, thank you very much.
Thank you, Samuel, and thank you, everybody, for your presentation. We have a couple of questions that maybe I would like to read out for all of you. So let's say the first question is for Christoph. Christoph, what do you believe mobile operator would do now to capture drone market opportunity?
Well, I think Ralph gave a great example of things that mobile operator can do and should do, I think, more widely and globally to work with drones. Sorry, and obviously this involved a lot of experimenting because this is a very new space, and Samuel also gave a great example through this PV loss mission. Each mission and each use case may be quite different, have different requirements and concept of operation, as well as a risk profile. And so the only way to get the cellular networks to become much more widely used, I think it's not only by adding cellular connectivity and SIM cards in drones, which will happen. It is certainly necessary, but it's also really to start programs within drone operators, carriers and cellular operators to operate and support those drone missions, because we are really in a convergence and transition space for this industry between the mobile connectivity, the digital industry, and aviation, and it will take some time for those different worlds to come together. And the best way to learn is to really experiment now and better qualify at the end of the day, how the cellular networks needs to potentially evolve to support those drone operation at scale. As Ralph mentioned, using a cellular link to transmit real-time data feed may create also some new requirements on the networks, and so it's important to test and learn to anticipate those needs.
Thank you. I also have a question for Ralph. Ralph, how will the drone market evolve in the next 10 years?
Oh, I really think Christoph just explained a lot. Thank you, Christoph. With respect to the ANSPs and telco operators, I think the biggest challenge is indeed to overcome the hurdles of this kind of existing industries. So aviation has certain needs. IT industry has slightly different needs. Safety must be the core element or the core principle of all of these kind of flights, because once really one thing happens on the planet with a drone, an incident or something like that, where a drone crashes into a plane or whatsoever, I think this market will be stopped pretty harsh and immediately. And in order to avoid this, I think it's absolutely necessary that all of these parts of the different industries work closely together in order to find the best solutions. And this not only means drone manufacturers, UTM providers, and telcos, but this also means to get the civil aviation authorities included. The key element for driving the commercial drone market, at least, will be, from my perspective, in getting an approval like it is today in the long areas in the US, to get an approval within a few seconds. And this is something at least we in Europe have to work on quite intensively. In the US, it's more a sandboxing, I would say. So it's still in framed areas and not widely open to the whole continent. But there must be solutions to, let's say, digitalize these kind of approval processes, which are pretty heavy paper-based still as of today, especially in the commercial segment. And we much looking forward to have the European regulation in place now in order to accelerate and start a discussion on that one. With respect to the market itself, I strongly believe it will go in the direction of BVLOS. That makes it much more efficient than this VLOS flights as of today. I strongly believe in the growth of the commercial market, and I also strongly believe that the private segment will erode a little bit due to that. So the more the commercial market grows, the private segment will go to the backyard again. We will see in the next 10 years definitely eVTOLs. Christoph mentioned them already. The so-called drone taxis. They are up from the start now. So there were trials in Singapore, in Dubai. There will be trials in Europe. And I think this will be something which will really fascinate the humans. Everyone knows how mobility on the ground is in its end phase, I would say. And I think these kind of drone taxis deliver a huge opportunity once they're properly managed. And this will also be something we will see in the next 10 years, I'm pretty sure.
Thank you, Ralph. So I think we only have time for one question, maybe one question for you, Samuel. What are the main prospects of our potential customers for your solution?
From our perspective, and this would be everyone who want to fly missions like, for example, corridor mapping. This could be construction companies with larger corridors, with larger constructions, and then also larger corridors. It would be mining industry with their big mines. This could also be in future cargo clients. But there are so many applications out there. I think the prospects are a real big number at the end.
Thank you, Samuel. There's also another question. I mean, we have quite a few questions that are touching upon regulation and BVLOS operation. One of the questions is maybe back to you, Rod, since you already touched upon this. what is the general forecast for less restricted low allowing BVLOS operation?
This goes to me, Ralf?
Yes, to you, Ralf. Sorry.
Yeah, I mean, at the end, it's pretty simple. You have the authorities who need to give you the approval. These kind of authorities want to be on the safe side. So what you need to do is you need to convince them. How can you convince them? You show them that it works somehow. This is what we did with the which Samuel also showed on the motorway here. We had a civil aviation authority with us. They took a look at the whole procedure we were flying here. It was not only based on the mobile network, which kept them even more convinced. And I think this is the crucial point to really show that it works and that it works safely. And then they get convinced. And I really also strongly believe that this is the only way to proceed here. It's really by doing.
Thank you. Thank you for that. There's maybe a question that I can ask Samuel. Is there or can be a backup communication in case of spot where LTE is not available?
For now, I think that would be the just the links what we have in the drones. So I don't know exactly if there would be something out in the market right now to have backup communication when we don't have the coverage of the LTE or less. So maybe Ralf, maybe you do you know?
Yeah. So it must be somehow radio frequency based. This should not be a surprise. And especially if you fly beyond visual line of sight, it's crucial to have the command and control sharp, live and in your hands. So once something happens, a copter drives in and you need to hoover down or something like that, you need to have a technology in place which enables you to steer the drone even if you don't see it. And from my perspective, this can only be a mobile network or a dedicated network which is especially built for that purpose. Last one, I would say, is extremely expensive and lacks the spectrum. That's why I really strongly believe there is no way around the mobile network itself for that.
Thank you. So there are a couple of other questions on this topic, but I guess you have answered all of these. One final, and it should be a brief answer, is what about frequency that are better suited for transmission than other? Are low bands needed for command and control? I don't know if maybe any of you want to answer this question. Maybe Christopher?
Well, I guess this is more maybe a question for Ralf.
Ralf?
In terms of the frequency band, right?
Being a spectrum expert, yes. Low band spectrum makes for sure gives you wider reach, so makes the network much more efficient. There will be attempts. It shouldn't be too low. So if you operate this kind of exercise on a LoRa network or 450 megahertz or so, it might be crucial because you really need, or at least we need for the systems of the ANSP, this is a demand from their side, we need this kind of trigger and tracking points every second, and even some more data which comes with that, which simply needs a little bit more bandwidth and a little bit more secured communication than you typically have on that low power wide area networks. Nevertheless, 700 megahertz, 800 megahertz, 900 megahertz are definitely crucial bandwidth in order to make it a quite efficient system. Yes.
Thank you, and that I think is all for now. We have more questions, but we will answer separately. Thank you for all your questions. And I hand over to Monica. Monica, over to you.
Yes, thanks. I just want to say thanks to everybody for attending this Fierce Markets webinar and submitting so many great questions. I'd like to thank our speakers for participating and GSMA for presenting today's webinar. This webinar has been recorded. You will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you again in the future.